we're just going to talk really quick about some domain restrictions if you're ever working with operations with functions or maybe compositions. But you basically have two things to worry about, and that's going to be fractions and even root radicals. So just going to do one of them at a time. So when you're doing fractions, what you guys have to take into consideration is that you can't divide anything by the number 0, right? So your denominator of your fraction can't equal 0. So for your domain restrictions, we're going to write it in interval notation. But all we're trying to figure out, or all we're worried about, is that denominator of 5x plus 2 cannot equal 0. So we're just going to solve for x and be like, oh, okay, x can't be this. So we're going to subtract the 2 over. Divide by 5. X can't equal negative 2/5. So that is the restriction, like x can't equal that. But to write it in interval notation, for your fractions, it's always going to be negative infinity to whatever number you're excluding, and then we do this little u thing, which thing is called a union, but it represents a gap, and then that same number to positive infinity. So basically, what it's saying is that we're excluding whatever that number is. So we're saying like every single number from negative to positive infinity except the number that makes that denominator 0. We come up to that, we skip over it, and then continue. So for our example, our domain is going to be negative to positive infinity, and that number that we're skipping in the middle is negative 2/5. So your domain for your fractions should always look like that. Negative infinity to whatever number we're excluding. We've got a gap, a space, we're excluding it, and then that number, everything after it. The parentheses means we're not including it. Like if it were a bracket, that would be including. Parentheses means everything up to it, so we're actually excluding it. Okay, so then your even root radicals. So that's your square root, your fourth root, your sixth roots. We are trying to exclude, or we don't want to incorporate our imaginary values here, so we don't want to take an even root of a negative value. So the expression under the radical should be greater than or equal to 0. And we did kind of talk about this with the graphs, like with the shifts. That's kind of what we did. But in your example below, we want x plus 5 to be greater than or equal to 0. So we're going to subtract or solve for that x. We want x to be greater than or equal to negative 5. So we're going to write it in interval notation. And hopefully from the graphs, we're like, oh, plus 5 means left, right? Correct? But we're going to write it in interval notation. So for your domain, your graph is going to start at the x value of negative 5 and go to the right. So for even root radicals, it should always be some number that you start with a bracket and go to the right. And like I said, we did kind of talk about that with the graphs, but that is it. Nothing else has restrictions. So if your problem doesn't have a fraction or an even root in it, you have no restrictions. There's nothing you need to figure out. The domain can be anything. So that would just be negative to positive infinity. So this guy here, no fractions. No even roots. Your fourth root, your sixth root, your square root. So no need to exclude any x values here. X can be anything for those. So you only have to figure out the domain restriction if you have a fraction or if you have an even root. If you have neither of those, if you have a cube root, that's not an even root. That's negative to positive infinity. Even roots or fraction, you've got to figure out what the domain is. Everything else, negative to positive infinity.